Hello, everybody. Thanks for joining this session of webinar about landscape modeling and BIM workflow with Lands Design. My name is Elham Gabouli, and I'm going to present you the first part of this session, which is an introduction to the software. And then later on, Francis Saya, my colleague, will continue the session by developing a real project using Lands Design, and then we will have a Q&A session in case you have any questions. So Lands Design is a BIM solution for landscape architecture. Basically, this software is used for 2D drawing, for modeling a project in 3D. It automatically generates a list of plants and other materials, and then there are several tools for animation and visualization of the project. There are two versions of the program. One works on top of AutoCAD and Civil 3D, and another works on top of Rhino. So you may decide which version to install, but with the same license, you may have access to both versions. Lands Design is used in the field of landscape architecture. Also, it is used by civil engineers in green infrastructure, in urban planning projects as well, and it is also useful for environmental projects. You can model, for example, a forest by using Lands Design easily. Let's see its main features. First of all, Lands Design includes an extensive plant database with more than 8,000 plant species. The plant database includes botanical information of plants and several filters that let us to select the adequate plants based on climate type, soil type, or any other parameters like, for example, the flower color, and so on. So in this way, we achieve the short list, and finally, we can select our own favorite plant species. Also, you can just look for your favorite plant by typing its name or its scientific name. Plants have different display modes. So this is the conceptual one. Then by one click, you get the detailed one, and by another click, you get the realistic one, which is the realistic, high detail models of plant species. In realistic display, you have also the access to change and to watch the seasonal change of the project. So you can shift from spring to summer or to winter and see that how the landscape will change its appearance. You can shift between 3D and 2D easily just by one click. So as you see in 2D, we have different blocks representing the 2D shape of plants and other objects. And in 3D, as you see, we have a 3D model. For inserting plants, we have different ways. One is inserting them individually. Another is inserting them by paint mode, like the paint of windows. So by moving the mouse on the block, you are inserting plant species. Another one is converting points to plant species. So just by one click, we convert all these points, or converting blocks. You can convert them easily by a specific command. We can insert the row of plants or a group of plant species by forest command. Continue, we can insert shrubs, indicating the number of units per square meter or per linear meter, or insert ground covers by indicating, again, the number of units per area. Inside of plant database, we have a good add-on, which is called Plant Editor. You can edit your plant species easily by this plugin, and then create a new plant species or modify an existing one. For example, you can change its color or any kind of its appearance as well. Another feature is that in Lands Design, we have powerful terrain modeling tools that let us to create a terrain by points, lines, or combination of points and lines. Once the terrain is generated, you can easily modify it by control points, by different commands, create a path or create a cut and fill inside of the project. You can divide the terrain as well, and Lands Design will calculate the volume of earth moving operation in each operation and in total. So finally, by one click, you obtain the quantity of whatever you have done on earth moving operation. You can also insert terrain from BIM files. If you have the access to digital elevation models or to point clouds or to LiDAR file formats, you can easily import them into Lands Design. What you do here is that you select exactly your area that you are going to import, and Lands Design generate a terrain based on these type of file formats. Once it is imported in Lands Design, you obtain also its topographic contours as well. Another feature is that we can import terrain from the web. So in this example, as you see here, you can insert an area by indicating its location on the map. So you can write it down on the map and then just select it from the area that it appears here. You can insert a mesh, create Lands Design terrain, and also you can insert buildings as well. So what you see here, we have imported the mesh, including the satellite image, and also the terrain. In case of terrain, you can convert it into 2D, or you can obtain the topographic contours of the imported terrain. This is just for those that have no idea, have no information or data from their site. So if you don't have topographic information of your site, you can easily import that from this way. And then another thing is that you can import 3D buildings as well. So in this example, we are going to show you how we do that by importing the Central Park of New York with all its surroundings. As you see, we select the area, and then what all we can achieve is the terrain, the satellite image, and the mesh of the area, and then all its surrounding buildings. So this is a nice way to have a rapid site production. For dynamic documentation tools, Lands Design has many options. So I want you to get the list of plants, species, zones, corresponding operation. You can add the image of plants with a specific command. You can add different labels and produce different layouts and plans and sections, as you see here. We have parametric Hardscape tools that let us to add walls and curbs, paths, parametric stairs, parametric fences even, and also there is a block library for furniture inside the program that let us to insert blocks easily. Also, we have irrigation tools that let us to insert the irrigation system, to draw the lines of the pipes, and Lands Design finally we calculate we will quantify the sprinklers and pipes that are used during the design process. For visualization tools, we have several options. We have walk mode, so you can by keyword just walk through your project. We have virtual simulation, so we can see how it would be in different seasons, in different and in the next year, how the project will grow. We have sun and shadow tools, as you see here. So this is specific for Rhino. So by indicating the location of the project and using the sun panel of the program, you can see that how the shadow will move during the daylight and during different periods of the year. Also, we have different render possibilities that let us to have renderings by applying compatible renders, and there are also some image filters inside the program. This is a rendering example of what we achieved by just using the Rhino render. So we didn't apply any rendering engine, just what it is included and native in Rhino. So so this is an example. And then if you apply any other rendering engine like Enscape, Twinmotion, V-Ray, or Lumion, you get also many interesting results as well. So these are totally compatible. And well, also you can create animations by applying a rendering engine, like in this example. The project is modeled by Lands Design in Rhino, and then the rendering is made by using Enscape in this example. Okay. Well, there are some specific features that are just available in Rhino version. Rhino is compatible with more than 50 file formats, including DWG file and SketchUp files. So it is compatible quite with whatever you can import from AutoCAD or SketchUp. Rhino provides freeform modeling, so this kind of forms and freeform geometries, you can create them easily by using Rhino. The licenses can be placed on Cloud Zoo. We have IFC support, so you can export your project into IFC and open it in other BIM programs. We have parametric design with Grasshopper, so you can apply algorithms to create geometry, to link geometries together, or to link data to geometry. And also we have the possibility to open Lands Design project inside Revit through Rhino inside Revit workflow. I mentioned parametric design before. This is something that you apply algorithms to create a geometry. So we have Grasshopper in the case of Rhino. And also you can apply this parametric design tool, or Grasshopper in our case, to connect data to a geometry and finally analyze it. So these are our Grasshopper components of Lands Design. So you can enjoy connecting these components to different algorithms, to different objects, and so on. This is just a simple example of what we can do by applying Grasshopper. Let's just insert some plant species, and then you're going to have some pots around these trees. And we want to have a pot according to the diameter of the plant species. So these pots are linked to plants. If you move the plants, the pots also will get updated automatically. Well, it's just a simple example, but you can apply algorithms for creating geometry, for, as I said, for connecting them, to making a relationship between them, and so on. However, this is not necessary to learn, so you should not learn Grasshopper in order to be able to work with Lands Design. But it's a big plus for those specialists that are interested in developing more complicated projects. Well, another feature is that we have environmental analysis possibility in Lands Design. So we connect environmental data through Grasshopper to a Lands Design project. Once we connect that, we can do automated analysis and finally get some results. Right now, we have announced and published the possibility to calculate the CO2 sequestration, that will the volume of CO2 which is going to get absorbed by plants of a landscape project when you model it in Lands Design. We have calculated the cooling effect, so this is also a calculation which is available. We have shadow analysis, so you can see that how much percentage of the floor will get covered by plants during different daytime and different seasons. And also we calculate the solar radiation that will get absorbed by plants in Lands Design. Well, regarding the BIM workflow, we have two options: IFC support, so you can export your project into IFC and open it in other BIM programs. Or we have Lands Design inside Revit, as what you see here is this one. So if you modify the project in Rhino, you see that everything can be updated in Revit as well. Revit recognizes Lands Design objects as BIM objects, so any kind of modification that you do on topography, on grading, and on vegetation are accessible and are recognizable in Revit as well. So let's see how is the design process with Lands Design. Basically, we can start designing by importing the terrain from the map, or if we have topographic contours, we just elevate them with a specific command in Lands Design and then create a terrain based on that. So once the terrain is created, we can do any kind of modification on the terrain by applying specific commands of Lands Design. Then we can zonify the projects in different zones. So we indicate that what is the label of each zone and what is the material and hatch pattern of each zone. In continue, we insert vegetation individually in a row or in a group of plant species, as you see here. Plants may have natural variation. When you insert a row of plants, you indicate the distance of plant species, and also the row can be combined of different species if you wish, or also the group of plants. The forest can be combined of different species. In addition, you insert and you apply hardscape tools. If you have walls, stairs, or paths, or fences, you can insert them and then place them on the project. And you can insert blocks from the block library or other programs, other blocks that are compatible with Lands Design. You can import them directly. And continue at any moment, you can shift between 2D and 3D just to see and to modify the project. If you are more happy to work in 2D environment, you can continue working in 2D environment. And finally, you see that how is the project in 3D. Continue, you get the list of plants, furniture, zones, earth moving operation, or terrain list by just one click. And finally, you render the project by applying Rhino render or any other additional render. So this is the workflow that basically we recommend. You can start technical drawing in Rhino, in AutoCAD, or in Civil 3D. You need one of them in order to work with Lands Design. Then the 3D modeling and all these 3D steps you can do in Lands Design. Lands Design is a BIM tool, so it provides you the documentation and the schedules. For visualization, you apply a render, like in addition to the native render of Rhino, or in case of AutoCAD, the render of AutoCAD. So you can have Enscape, V-Ray, Twinmotion, or Lumion, for example. You may apply virtual reality headsets and walk through the project in virtual reality, or print your project with a 3D printer. For documentation, you can export documents to Excel or to PDF, or also you can directly print your drawings. You may have collaboration with other BIM programs like Revit, or and also other programs like 3D Max or SketchUp through IFC, and also through other file formats that are compatible. If you have geographic data like GIS files, DEM files, or point clouds, or LiDAR results, so you can introduce them directly into Lands Design, and Lands Design can generate a terrain based on them. So in conclusion, what you can do with Lands Design is the whole project. So you can have 2D, 3D model, sections, different plans and drawings, and so on. And in summary, just let's mention again that Lands Design is available for Rhino, AutoCAD, and Civil 3D. There is a 90-day free trial of the program, but we recommend you to try it out for sure. We have permanent licenses. We have free technical support for all our users, even those that are using the evaluation version. And there are educational and lab licenses for schools and for students at a very reduced price. Up to now, do you have any question? Or I'm going to ask Frances to share his screen.
Hello, everybody. All right, thank you very much, Elham. Well, we'll see now basically the features that we have seen in this nice presentation, but with a live model. Okay, I'm going to show it live, so you will get a bit of a feeling of working with Lands Design. How is it working, and how easy it is to do stuff with landscape projects in Rhino. So first of all, let's take an overview of the Lands Design toolbar. We've got first a long toolbar with all the commands, but all of them can be found also distributed to these other 3 different tabs. First of all, we have the commands to insert different landscape elements, such as the plants, also civil work objects, or terrains. Okay. There are different ways to insert plants. We can insert them, as we have seen, like individually from points, from blocks, or in a pin mode. We can arrange them in rows, in forest, in shrubs. We can also insert ground covers, and also use this topiary command, that will wrap volumes with 3D plants. And then we've got civil work elements. They are parametric objects like the wall, the fence, stair, the path. Or we can insert elements arranged in rows that we can browse from the lands library. Okay, there is a library of 3D objects that we can use to populate the project with urban furniture, fixture, different blocks. Okay, but of course you can use any other geometry, any other block that you have in your model. We'll see some of the terrain modeling tools as well. We have seen already how to import terrain from the web. Okay, and well, here we've got all the documentation tools, all the relation commands, the tools to create lists. We can list all these different elements: plants, library blocks, sprinklers, pipes, zones, and terrain land movement. And we can export this list to Excel, for example. And we can find other documentation tools to insert labels, photos, other labels for indicating some information with the arrow, dimensions, slopes, or areas. Okay. Also, we have this option to show some 2D plant shadows at the bottom of the plants. And finally, we have some additional tools here. The two first open the Lands Edit panel that I have already opened here. The next one opens the Lands Animation panel that we will use to do some easy videos. And we have other commands to open the plant database. There is a filter application included in Lands Design to apply some filters to images that we can load. Basically, the renders that we can shot, we can also load and apply some filters. And some other tools to set viewpoints or navigate through the project in a walk mode. First of all, let's take a look at the Lands Edit panel, because this is the most important dialog that will let us edit everything that we select directly in the model. So, for example, if we select any of these plants, okay, like this individual plant we have here, we will see in the Lands Edit panel all the features related to this plant. So we'll be able to change the size of the plant. We will be able to change the species that we have here. So we'll be able to edit everything. And when nothing is selected, we will be able to change the display of the plants. So right now we're seeing the plants with the realistic mode, which is the one that integrates all the textures and materials on the leaves and trunk on the different parts of the 3D plants. Okay, basically this is a 3D representation that where plants will show the better representation of them. And when we shot a render, these plants will be replaced by an even more detailed 3D block. That means that we will get a better result even than what we see with this preview. Okay. There are other representation modes. We can switch to elevations. Okay, they will orient towards the camera, and they are maybe appropriate for elevation views. Also, conceptual shapes. If we just want to see kind of volumes of the plants, okay. Imagine a Euro park design where you just want to see the conceptual shapes of the plants, just to see a green mass over the city. We have also the detailed representation. These are more lightweight objects, so we'll be able to work in a more efficient way with these blocks. But still, if we use the realistic ones, we can also choose this billboard representation, which are basically surfaces with the corresponding texture and transparent map. All right, so we'll be able to work with a large amount of plants and still have a very good performance. Okay, and of course, the display mode that we choose matters in terms of performance. So still, using rendered display mode with this option will enable us to work with a large amount of plants and have a good performance. Okay. All right, but since it's a small project, I will even choose the 3D. And just a little bit below, we can set here specific season for the document. So that means that when we shot a render, the plans will show a specific representation that they have assigned for each one of these seasons. Okay, even the preview of these plans, what we see here, have different representations according to the season. We can switch to winter time, and some of the plans that have this double representation will show the corresponding preview. Okay, but again, remember that these are just basic representation of what we will get when we shot a render. Okay, I'm going to switch back to Spring. Okay. Well, sometimes when you load specific representations, it loads some images that are assigned to the 3D plans, but this is just computed once. Then later on you can switch from one season to another, and since these images are loaded, it switches very, very quickly. All right. Also from here, from this dialog, from the Lands Edit panel, we can also set specific geolocation. We can also determine how objects are assigned to layers. Okay, so for example, when we insert new plants, they will go automatically to the planting layer, and it will be easier, to show or hide all the plants from the model. Okay, so if I hide the planting, all the plants that are in this layer will hide, except this mass over there that probably was set to a different layer before. Also, from here, we can select all the plants from the same species. Okay, we can just navigate through this list and select all the plants that have the same species. And from this, the lower part of the dialog, we will be able to change any of these display modes for the plants. Okay, we'll be able to change, for example, the realistic plant to any other one that we have in our folders. Okay, there are over 600 or 700 different 3D plants, but that cover the realistic representation of more than 8,000 species. Okay, which is the amount of species that come with the plant database. Also, from this dialog, we will be able to switch from 3D to 2D. So when we work from the top viewport, we'll have the feeling that we're working in the classical 2D mode, okay? Just using Rhino tools to generate 2D lines, contours, and edit tools in 2D. But we'll be still working with 3D objects that we can, visualize when we select this button, okay? All right, let's start modeling stuff here. I mean, this is a project that is already started, but we can continue by developing this area of the project where we'll have some topography. And well, before going to the topography, we're gonna insert a zone, okay? So we have already a few zones in this project. And basically zones are textured surfaces that also include a label that indicates the area of that zone. And this is very useful in the early stages of the design process because you want to know the amount of, the areas of the design that you have in progress. So if we move to the top viewport, I can work now in 2D. I gotta define an area on this empty space, and I will use this zonify command. When I click this dialog, I have the option to click on an empty space or select this boundary option in the command line. So we'll need to select a curve, okay, a closed curve, obviously. And finally, we'll need to define here a label, title for the label, and some other features like the 2D representation defined by a hatch pattern, okay, or also material for the representation of this zone when we switch to a 3D view. Okay, we just need to place the label somewhere here, and when we switch to 3D, we'll see this this texture on top of it. If we select the zone, now we can go to the Lands Edit panel. We can change the name of the label. We can change hatch pattern, And we can also change the material. So we have here a library of materials that we can change for the 3D representation of this object. Okay. Of course, if you have your own library of materials, you can use it, all right, freely here. So you can use V-Ray materials or any other Rhino materials that you have created. All right. Now let's insert a plant. Okay, this is maybe the most fun part of lands design, where you need to insert different plants. And when we run this plant command, we already see a list of the plant species that we have inserted in this project. So in an empty file, we'll get this list blank. All right. So we will need to browse to the plant database and search for the desired species. So here we can see all the list of species. There are some filters here according if the plant species are already added to a favorite. Okay, we can select favorite by double click on this heart icon, or plants that are suitable for vertical gardens. Okay, there is a selection of them as well that have a specific realistic representation. Okay, or well, plants that come with a specific realistic representation. That means that the 3D representation has been designed specifically for this plant species. And maybe we can just show them all, right? And while we have here many different filters to search for a specific plant according to the plant type, according to the leaf type, and many other details, right? And we can select any of them from here. I'm gonna just select a random one. By the way, we can also access to the properties of any plant. You can modify any of the details if we click on that edit button. So here we will be able to change any of the details for this plant species, even the display mode that we're using. So we can assign different 2D ground for that plant species, and the changes that we do on the plant database will affect other documents. So these changes can be done by document, or in this case, in the plant database. So they will be available in other projects when we use Lands Design again. So as you can see here, we have a bunch of 2D grounds for plant species. But if you have your own 2D representation, you can add it to that folder, and you can use it for the 2D representation of any plant. Okay. Also, if we switch to the render tab, we can select a different plant representation, or we can launch the plant editor with this button and develop our own 3D plant. Okay, there are two versions of this plant editor. This is the newer one, which doesn't come with a Lands Design program, but you can download it separately. And the older one already comes with the Lands Design. But depending on the plant species, you will see that the realistic block is generated with one editor or another. But here you have all the parameters to develop your own plant. Okay, your own parametric plant, just playing with all these features. Okay, there are also a few templates, and well, you can develop many different plant species if the one that you want to achieve is not maybe available in the plant database. I'm gonna close this. I select this species. I need to close the dialog first, select it, and now we can define the size of it and place it in my model. All right. So just got here a couple of hints. And now I'm gonna zoom in. I can select this plant, change any parameters. And well, also, there are different levels of detail for realistic plants. And if I select this species, again, I scroll down, I will be able to switch from one level to another. So we can also use maybe a lower level of detail. And this is just for getting a better experience about working with these plants. But again, when we shutter render, these plans will be replaced by a much detailed ones. Okay, and well, still we can select this and also choose with the higher representation. Okay, so we get a much better plan. Okay, let's work with terrains. So I'm gonna create a terrain on this empty area, and we can see that we have already some contours. And this is a typical situation where we get a DWG file with a bunch of 2D contours that they are not necessarily in the proper elevation, such as this case, where we have all these curves on the zero elevation. So Lands Design provides a tool that helps you to elevate these curves according to an interval of distance. Okay. In order to work more properly, I'm gonna switch some layers off. All right, so I still keep this this layer. So I'm gonna elevate these curves with this command, and I can define the start dimension and the increment of these curves, and I will need to draw a line that that we need to intersect with the curves that I want to elevate, and they will be elevated according to this interval. If I click apply, I can see that the curves have been elevated 1 meter in this case. Right? I can show this back, and now I am ready to create a terrain. Remember that terrains can be created from curves or 3D points or a combination of both. And by default, well, terrains are meshes, so they use a Delaunay triangulation, but we can use this gridded surface shape to triangulation to be able to define more level of detail of the resulting terrain. Okay, so of course, the smaller the cell is, the more accurate will be with the given data. Okay. All right, I'm gonna say that 1 meter is fine by now, and now I just need to select all the curves that I want to use as input data for the terrain. All right, so I have the terrain created. This terrain doesn't have a specific boundary. It takes like the bounding box of all these curves, but there is a command that will help me to trim the terrain according to specific contour or boundary. So I'm going to use this pick boundary command to select the terrain. Then I need to pick a closed curve, and I have here already a curve, okay, that I will use for the boundary of my new terrain. And as a result, I get the terrain already trimmed by this boundary curve. Okay. Of course, here there is some work that I previously created in order to trim this terrain, but you will need to, use 2D tools constantly, to do operations with terrains or with the 3D model. Right now, if we select the terrain, we can check its properties from the Lands edit panel. So we can go to this dialog, and here under the terrain properties, we'll be able to change the cell size. We'll be able, for example, to uncheck this base. Sometimes this is convenient because we don't want to see all the edge of this mesh. Or we'll be able to go to the contour lines and change the number of contours. So when we show this project in 2D, this model in 2D, we'll see the terrain as contours. Actually, here I'm still seeing the original curves. Okay, they are not linked to the terrain anymore, but their control points are somehow integrated into the terrain. So I will be able to select these points, and change the topography of the terrain. We'll better appreciate this if we show it in 3D. Okay, and well, we can keep on working with the terrain topography by pulling and pushing these control points, changing their position. Okay, but these control points are based on the control points of the original curves. There is an option here to show the 2D and 3D representations simultaneously. That is quite convenient for the terrains. So it gives us a better feedback of how the topography goes. By the way, by default, the contour lines are set to a total number of contours, but we can change this to a specific distance between contours, which is maybe more appropriate. Let's say every half meter, we're going to draw one contour. Okay, there is also some feature to name contours with different attributes and land types or colors. All right, terrain is done. Let's explore some other features that we can apply on the terrain. If we get close to here, we can see that there is some nasty gap here. We don't want this. And imagine that we just want to flatten this area in the in the intersection with this edge of the park. So there are different ways to achieve this. And one way is basically using one of the commands to do some operations on terrain, such as this one that will apply a cut and fill. So I'm going to draw a rectangle here, maybe starting from this vertex, and I'm going to draw maybe under here. All right, now I need to rotate this a little bit. And as long as this is a flat curve, I will be able to apply a cut and fill later on. So we can rotate this slightly. All right, maybe a little bit more. There we go. Now I'm going to move it next to this point. And now we can even move it maybe a little bit further, since we have already here a wall. A little bit up. Okay, that's fine. Now we can run the cut and fill command. We'll select the terrain. We will select a slope, an angle around the contour of this curve that will intersect with the existing terrain. Like 30 degrees is fine. Here we want the kind of a slope. And finally, we need to select a closed curve. There is this additional option to divide the area. If we divide it, if we say yes, we'll be able to assign different material to that different zone. But in this case, we're going to say no. Finally, we'll pick this curve. And as a result, I get this area totally flattened. Okay, I can already hide this curve. Again, it's not linked to the terrain anymore. And this is just an example of how to manipulate the terrain once it is done originally. Let's see some more operations. Actually, if we see this in wireframe, I have some curve over here. I think it's in a hidden layer. Okay, here it is. So you have this curve that it's meant to be used for adding a path on that terrain. And I have this curve already on the 0 elevation. That means that if we apply a path command on the terrain, we're gonna bury all the volume in order to meet the elevation of this curve. And we don't want that in this case. So first of all, what I will do is to elevate this curve to be adjusted to the terrain topography. And this is something that works for any object. So we can select that object, in the case a curve, and say adjust to the terrain. This is going to be elevated to meet the terrain points. Okay. Now we could change the elevation of this curve, and when we apply the terrain the add path command, we will see how the terrain try to fit the position of this curve. I'm going to switch back to render it, which is nicer, and run this add path command. So I need to select the terrain, define the path width, let's say 3 meters, and an angle. In this case, I'm going to define maybe a steeper angle. And in this case, I'm going to say yes to add a division, okay, because we want to add a different material to the terrain. So finally, I will select this curve, and I will get as a result this path over here. Okay. Now, when we select the terrain, we can see that the control points of this path have been integrated also onto the terrain. So we can select any of these control points, elevate them, and the path will, change the elevation according to these control points. Okay. Also, if we select the terrain, we go to the input data. We can see here the list of all the operations that we have been doing. So we can select this path operation, change the cut and fill angle, change the width, for example. Okay, change any of the details. So we are still working with a parametric object, okay, and change any parameters even after having created them. Also here we can find the subdivision of this terrain, so we can make a zone out of it. So we can also list that zone when we generate a list of zones, and so on. Actually, if we select that subdivision from here, that's from where we are able to assign a specific texture. I can browse to the library of materials. Maybe we'll go to site, and maybe we can select this gravel. All right. Okay, so well, some other operations that we can do on the race. We have seen the cut and fill, the path, the boundary. Okay, and we can check the volume of earth moving anytime by selecting the terrain, and we can see here the amount of cubic meters that have been added or subtracted according to this operation, comparing it with the original terrain. All right, and these operations, this volume of cuts and fills can be displayed in list, as we will see in a moment. Now let's insert some more plants over here. So I'm going to work from the top viewport, and maybe we can insert a forest on that area. So let's see if I have already some contours for that, or otherwise I will just draw the forest directly in the field mode. Okay, I'm gonna work in 2D this time. Run the forest command. In this case, it asks me to select one specific species. Okay, for example, some of these acer. And here is important to make sure that the natural variation option is on, because that will make that all the plants are not exactly the same height and will give us a more realistic feeling to the group of plants. Okay, all same for the random rotation. So each plant, even though they are the same block, they will vary from rotation, from height, and will give us the feeling that every plant is different from one to another. From the forest tab, I can set here the parameters of this forest, total number of units, separation of minimum separation of the units, or we can choose this array mode. Okay, but well, when I'm done, I click OK, and now we can either select a boundary. Actually, we could select the original curve, but now I want to have a different one. So I'm just gonna draw it using this polyline option in the command line. I'm gonna disable this, and I'm just gonna draw here the boundary of this forest. Okay, and one important detail: as long as you have this option here enabled, all the plants will project automatically on top of the terrain. Okay, we don't appreciate it from here, but we'll see it immediately how the plants are already on top of terrains. We'll need to close this curve. If we do right click, the boundary will close automatically. But if we now check this from 3D, we can see that the plants are already sitting on top of the terrain. Okay, and by selecting the plants and going to the forest, we can change the number of units, for example. From here, we have a few options to do a redistribution, because this is a totally random distribution of plants. We have here the option to add a hole. Okay, for example, imagine that we want to clear an area on this forest based on this rectangle, because there is some construction on this park or for any other reason. So we can say add hole, select this curve, and now there will be always an empty area around this part of the forest. Okay, we can also use this array option. Be careful if you set values that are maybe too small. So I'm gonna define a bigger separation, okay? But as you can see here, there are many parameters to create forests arranged in this array way or in a random distribution and so on. Okay, you can play with all these parameters. Also, we have the option, maybe I'm gonna set this to a bigger separation. And also we have here the option to combine different plants in the same forest. So we said that we want 2 elements. We'll see that 2 species hang from this forest option. And just by selecting one or another, we'll be able to change the plants of this path. Okay, and change the height, change the species, and so on. Combine different species in a forest. And actually, this is something that also works for plant rows and other elements. Okay. Also, we have here the ground cover command. This is actually a tool that lets us cover areas with 3D plants that have a specific different representation than individual plants. If we browse in the plant database, we can see already species that have this specific, that are suitable for ground covers. I'm gonna show all to have maybe more options here. All right, so let me select this option and we can click OK, and now draw maybe through a rectangle a ground cover on this palette. Okay, sometimes okay, I'm gonna show wireframe. So I think the plants were too small here. That's why we don't see them properly, but let's change that to a bigger size so we can also see them in 3D. Okay. And at any time, if we work from 3D or in 2D, we can select objects and they will have different control points, to change all the boundary of their contour. Okay. Not only for ground covers, but we have seen it as for terrains, for forests. Okay, we'll be able to edit objects through control points very easily. By the way, either the forest or the ground covers are used to create vertical gardens. Okay, imagine a situation where we want to have a vertical garden on this wall. I'm gonna isolate it 1 second. Okay, I'm gonna work from the right view. I think it's maybe better to work from the left view. Okay, and now imagine that we have a vertical rectangle. Okay, here. I don't know if I placed this on the right position. Oh, here it is. So I'm just gonna move this next to the wall. All right. Okay, there we go. So I'm gonna just move it next to it, and now I can create a ground cover or even a forest using this vertical curve. So the ground cover will be placed exactly on that plane of the curve. If I run the ground cover command, I can even select the same species, and now I will select this rectangle. So we'll get the ground cover that I can also bigger. Maybe not so much. On top of the wall. Okay, I can delete this curve or even hide it, and we'll get a vertical wall this way. I'm gonna show everything back again. And maybe we can see some of the civil work elements. So maybe it's worth it to mention the wall object. This is a parametric object defined by a thickness and a height. Okay, and it can be also created from curves. So if I select this curve over here, I will create, a wall all over the terrain. Since I have this option selected to project, the object I create on top of the terrains, now this is half, on top of the terrain and half of that. So you have always the option to say this wall to do not be adjusted to the terrain. So we'll be able to have it totally flat. Okay. But we don't want to have a wall all around. Actually, we wanted to choose a smaller segment. Okay. But all these walls over here, as you can see, have been created using this command. And once they are created, we can apply different smoothness in order to have more curved contours. We can change the justification, or we can change the height if we want. Okay. All right. Let's take a look at the documentation tools. Maybe first it's worth it to mention the row tool. So the row tool lets us arrange different elements along a path, and these elements can be either geometry that we have created in the model, could be blocks or even any solids, or we can browse these objects from the block library. And here we can see all the elements that come with Lands Design. There are different elements from stones to lighting objects. Maybe we can select one of them. And okay, there are different features to align or orient this element along a path. And finally, I'm gonna select this path curve. Okay. So I have now, these street lights following this path, and they are a bit separated from the axis because I have defined here a distance to the axis. I can make this closer. Okay. And at any time I can change the features of these elements just by defining the separation, or saying that I want total number of 6 elements along this path. All right. So let's we have inserted zones, we have inserted plant species, terrains, block elements. So let's list all this stuff. I'm gonna show this in 2D. And well, first of all, I can insert a plant species. So this is gonna show me in real time the amount of units we have for each one of the species. Okay. For example, here we have what's that? This is a forest, and of Acer platanoides and Acer capologium. So if we change the number of units, for example, let's say 60, so we can see that this number has updated. Okay, so we have a live connection between this list and the forest, and the real plants, the amount of plants that we have in the model. We have also inserted zones, so we can insert here a zone list. We have inserted also terrain, so we can measure here the amount of volume that we have added or subtracted with these operations. All right, and any change that we do on the 3D element will update on this list. And if we select them, we can also customize the information we want to see here. For example, for the plant list, we can also show the density. So for those species used as ground covers, we can see the density that we have on them. Okay. Yeah, Alham?
Just as a comment, whatever you see here that you're inserting in the model environment, you can actually do that on different layouts at the end of the day. So just take it into account that at the moment of creating different layouts, you can enjoy connecting different layers, turning on and off layers, and produce different types of layouts by this data.
Yeah, thank you. Actually, we can also filter the plant that we are seeing in this list by a specific region. So imagine that we want to see the plants that are only in this part of the project. Okay, so we can tell this plant list to go to filters, to select by region. So if I pick add boundary, I can select this boundary, and the list is gonna show me only all the species that are included into this boundary. Okay, so I have different, I can have now a different list of plants by the different regions of the park. Okay. Also selecting the list, I can show here all the fields that I want to display. And finally, I can export that to to Excel or to an HTML file. Okay. Okay, so actually here we can see very quickly some of the other features. For example, the zones, either the plant shadow tools, okay, or the slope tool to say, okay, I want to see the slope of that path. Okay, by selecting this curve, it's going to give me the slope that is measured from the initial point to the end point, calculating the difference of height. Okay. All right. Let's see very quickly before finishing some of the animation tools. Okay, I'm gonna hide these plant shadows right now because I want to show this in 3D. And in order to get even better pre-visualization, I can open the sun panel, which is a Rhino feature. I will get a better lighting on the scene, okay, based on a geolocation and daytime at a moment of the year. So I've got here a camera path with this curve. Okay, now I'm going to use this curve for the path of my video. So I'm going to move to the Lands Animation panel. And here I have this button to set a camera path. So when I click it, I need to select this path. Once this curve is selected, I don't really need to see it, so I can hide it again. And maybe I can also hide these curves. All right. This one too. And now I can define the parameters of this animation. So we can set the frames per second or the total duration of it. And we have other tools, other parameters to set the camera to a fixed point and look always forwards, or to look to a fixed point or to another curve. So you can play with all these options over here. Also, we can apply some season change simulation during the scene. Although these are only you can only appreciate these changes if you use the renderer, not the Rhino display. And here you have these two options. We can record the animation using the current display, or we can use the current render. Of course, this option will show the render for each frame, so it may take time. But if you want to have a quick preview of how the video will look like, how the virtual tour will look like, you can just choose this option and here play the animation to get a feeling of how this will look like. Okay. And finally, I've mentioned before that there is this walk mode. When you hit this button, Lands Design puts you onto the ground, and just with the cursor, you can navigate through the project, just clicking, doing right click, left click, and with the mouse pointer, you can just navigate. With the wheel, you can change the speed of walk, okay? And with the tab, you can also go to fly mode, and well, it's a nice feeling to discover your design this way. All right. Okay, so that's pretty much what I wanted to show you. There are more, of course, to find out. If you go to the Lands Design website, so you will be able to see tutorials. You have projects here to see examples of how Lands Design is being used. You have here plenty of learning resources.
Well, just let's mention the first one. Yeah, the first one is the courses, and if you click on course, the previous page. There's a free course platform of Lands Design, which is available in 7 different languages by subtitle. So there is an online platform. You can enroll in that platform for free and then learn Lands Design by your own. Step by step, the course includes several practices, several exercises, and lets you learn all features of the program. So thank you very much, everyone. Is there any question? Just feel free to write it down in chat box. Well, so great. Thank you. Seems that there is no question.
Yeah, thank you very much. Please feel free to write us with any suggestions, any doubts or questions. You have here our contact email. As Elham said, we based land design development on our feedback, on your suggestions. So they will be very welcome if you want to share your thoughts in order that we can improve land design. Okay, thank you. Thank you very much.
Enjoy 90-day free trial of the program. Have a good day. Bye-bye.
Bye-bye.